Good morning, everybody. Today we're going to talk about Pearson's correlation coefficient. The variable used for that is R. Now, this correlation coefficient always has to be somewhere in between -1 and +1. If it is +1, the slope is positive and the points form a perfect line. If it is -1, the slope is negative and the points form a perfect line. So as you get closer to 0, the points get more spread out. They don't look like a line. So just a few examples here. Looking at this one, there is a positive slope, so we need a positive correlation coefficient. But the points are a little bit spread out, but there is a pretty much general linear theme here. So that R value would be about a 0.8. This next one, the slope is negative. So our R, our correlation coefficient, has to be a negative value. And they're pretty gosh darn close to a line. If we were to draw a line in there, that one might be a little bit off, but otherwise they're almost dead on a line. So negative 0.99 or negative 0.98 or something would be a very good guess at a correlation coefficient for that one. This one, they're all spread out. You can't really tell if we're going up, we're going down, or what's happening. So that R value would be really close to 0, maybe a 0.001. So there's really no linear pattern there. Now to calculate this, we have this whole formula to get our correlation coefficient R. The sum of all the x values minus their mean times the y values minus their mean divided by the square root of the sum of the x values minus their mean squared times the sum of their y values minus the y mean squared. So x and y are your original data points, and x bar and y bar are the means of those variables. So the first step you got to do is find the mean of your x list and your y list. So here's kind of an example of that. Given this list and this list of values. So our x's are 1, 2, 3, 4. Our y's are 12, 14, 17, 19. The first thing you got to do if you're going to find correlation coefficient by hand, you need to find the average of the x's, which I did, 2.5. And then the average of the y's, which is 15.5. Then you take each x minus the average of the x. So 1 minus the 2.5 gives you the negative 1.5. 2 minus 2.5 gives you the negative 0.5, and so on. You do the same thing with the y's. 12 minus 15.5 gives you the negative 3.5. 14 minus 15.5, negative 1.5, and you keep going. Then you multiply those two values together. Negative 1.5 times negative 3.5 gives you 5.25. Negative 0.5 times negative 1.5 gives you 0.75. Then you got to take each of these values for our denominator part, x minus x bar, you got to square them. So negative 1.5 squared is that, negative 0.5 squared, and then to do the same thing with the y's. Negative 3.5 squared is 12.25, negative 1.5 squared is 2.25. The sum of means you add them all up, so these numbers down here are just these three columns all added up. So then it's the sum of this over the square root of the sum of your x's times the sum of your y's. If you do that, you get 0.99654. So what you can tell from that is these points have a positive slope and they pretty much form a line. Now here's how you do it on the calculator. So I got my calculator here. I got my XY list. First thing you need to do is turn your diagnostics on. If you go to mode, I'm just going to blow this up a little bit so maybe you can see it. So I clicked on mode, and then you got to go down to stat diagnostics. If you notice, mine says off. We want to turn that on. So that's first step. So mode, down to stat diagnostics, turn those on. Get out of there, then you go to stat, edit, to get to your lists. Now our list 1, our X list, is just 1, 2, 3, 4. And our Y list is 12, 14, 17, and 19. Now to get your correlation coefficient, your R, you go to stat, over to calculate, and you're going to do linear regression. Now there's two options for linear regression. There's number 4 and there's number 8. It really doesn't matter which one you do. This one looks more like mx plus b. This would be like y-intercept plus slope times x. So I'm just going to use number 4 this time. Our X list is our list 1. Y list is our list 2. We have no frequency list. Now if we just go to calculate, you can see there we get y equals ax plus b. A is 2.4, b is 9.5. R squared is 0.9931, and our R value 0.99654. Which is what we got doing it by hand. So you can do it by hand and then you can check it using the graphing calculator. If it is a longer problem, I would recommend just using the graphing calculator because this process of solving by hand is a lot of work. If you have any questions, please let me know.